Luna, the moon, Chanda. It has captivated humanity's imagination since we've been on the planet Earth. We've visited, we've explored, we've traveled, we've tested, we have failed, but we have been resilient. The moon guided those exploring the new worlds on their ships, and today it guides spacecraft to explore newer worlds. We have learned from our collective time in space. 60 years is all that humanity has been in space. We've learned a lot, and there's much more to contribute in the years to come. This is one of the most iconic photos in history, Earthrise. It is the moment that 3 humans traveled around the moon for the first time and pictured the blue marble, our home. The collective knowledge of humanity is everything in that photo. The interesting thing is, it almost didn't happen. The crew that was sent around the moon was not trained on photography. They were given, here's a camera, point and shoot. So that image has inspired generations. And it almost didn't happen. But did we learn from it? Well, you bet we did. Ever since that day, every single space crew, astronaut crew that flies into orbit, gets detailed training on photography in order to capture that essence, to tell that story. Fast forward nearly 50 years, 2018. There's a human living in orbit, taking photos outside their window, capturing 3 humans exiting the atmosphere, launching on a rocket. There's not even a handful of these types of photos in our world. Yet, they were able to capture that moment. And sitting on top of that spacecraft was Canadian astronaut David Saint-Jacques, who recently returned from 6 months in space. And this is where he lived, the International Space Station, a collaboration, an international collaboration of 16 different nations, $100 billion, decades of time and investment to have the world's only orbiting laboratory, entirely dedicated to science research. It also represents sustainability, self-sufficiency. Everything you see there has to operate by itself, with no help or little from the outside world. It challenges and pushes the boundaries of our knowledge as humans, and each day we're up there, we learn something new about ourselves that we didn't before. So that's photographing near home. But it's led us then to think of how do we capture other worlds. This is a photo from Mars of the Sojourner rover and the Pathfinder lander in 1997. I remember sitting in a science center watching this happen. This is the first time we've taken a photo of a rover on a different planet. It was only designed to last a few days, maybe a handful of weeks. It lasted 3 months and gave us incredible science and data to be able to understand what we could do next. So did we learn from that? Yes. We learned how to land. We learned how to communicate. We learned how to plan and know where to go and look and investigate new rocks or new places. Now, if you thought getting to Earth was a challenge, well, getting to Mars is an even greater one. Imagine trying to send a pin from Vancouver to Toronto and hitting a bullseye. That's how challenging it is to get to Mars. So, our collective humanity, we were able to do this. But we're able to do it again, and again, and again. This is a shot from the NASA's Mars Reconnaissance Orbiter. Now, if any of you are photographers out there, you can appreciate the challenge of trying to capture a moving object from another moving object. That's exactly what you see here. The Curiosity rover that's currently on Mars, conducting new and untouched science, was 1 minute from landing on the surface of Mars in this photo. Teams spent months and months trying to plan how to take this one shot. If they were half a second too late or half a second too early, you just see an empty photo. Add that to the challenges of trying to send a spacecraft to Mars, let alone get it off the Earth. Incredible challenges that we have not only done together, but learned from along the way. And occasionally, we turn that camera onto ourselves. A cosmic selfie, let's say. This is from Saturn, the Cassini mission, which had flown for more than a decade, decided to turn its camera and take a photo of Earth. The pale blue dot, in the words of Carl Sagan. 1.6 billion kilometers away, 11 times the distance from Earth to the Sun. Everything we know is that little dot. So I share with you some of these images to help understand how we have progressed as a human race to push the boundaries of what we can do. We can explore new worlds. We can live and breathe in an environment where we really shouldn't be alive, but we can do it. Now, this is one of my favorite shots. It is an astronaut doing a spacewalk outside the International Space Station. It's about 340 kilometers above us, the distance between Vancouver and Kelowna. And he's looking out to the front of the space station. For me, the most iconic piece of this photo are two things: Canadarm1 and Canadarm2. Canada is a leader in space robotics and contributed a robotic arm both for the space shuttle and for the space station together. Then you see modules. The International Space Station, as I mentioned, is an international endeavor. You have a Japanese module attached to an American module attached to a European module. You see the space shuttle. I'm of what people call the shuttle generation. It was the most complex thing built to launch like a rocket, take people to space, and land back on Earth just like a plane. And then the space station came about, the most complex thing that humanity has ever designed, built, and operated. You see the world below us. Everything we love, everything we know, everything we do is on that blue marble, the thin atmosphere that keeps us alive. And then you look past that into the darkness, the vast expanse of space, the unknown. What will we find? How will we get there? What do we need to do to take that next step? So I've had the opportunity to explore a lot through my career. But the ember that lit my fire, I have to thank my parents for. They pulled me out of school one day and took me to go see Canada's first female astronaut, Roberta Bondar. Not too far, just across on Vancouver Island in Victoria. And it was that day that has changed my life forever. Now, each one of you will have a spark. Maybe you found it, maybe it's still to come. But when you do, you will know that you will absolutely dedicate everything you do in your life to achieving that goal. We all go to school, formal education, bachelor's degrees, master's degrees, PhDs. But sometimes you end up learning things that you never thought you would. I was fortunate enough to work with 2 international teams to put experiments on the space station. There's 200 experiments going on at any given time on that laboratory. And I had the chance to work in the domain of life sciences and biology and understand how the human body reacts in space. I didn't study that when I was in high school. I didn't study it when I was in university. But with the help of my colleagues, I taught myself. I learned. I expanded the boundaries of my own knowledge to be able to help and contribute back to understanding just a little slice of the knowledge that it takes to live off this planet. And we do that by testing. So the first photo was there. I flew on a parabolic flight to experience microgravity, to understand what it's like to live and work in space. But if any of you have taken up scuba diving or enjoy the oceans, we know more about space than we do of our own oceans on this planet. There was a moment I was underwater breathing, which humans are not supposed to do in these extreme environments, and my dive buddy was in front of me, and I took a moment and turned myself around, and I saw the depths and darkness of the ocean. It's much different than a pool. You can't see how deep you're going. You can't see how far it goes. And I realized in that moment how small and insignificant we are as humans, not only in our world, but in our universe. Training. We all go to school, we learn. But it's continuous. Never stop learning. So I was able to learn from others, from teammates, colleagues, people in North America, Europe, and Asia, across the world. Now you're all connected. You're always connected, and you're always learning. And that is an important key. But not only is it important to be really good at what you do and to love what you do, it's as important to be able to communicate what you do, just like what we're doing here today. Keep that in mind, because the more you can share your own journey, the more you can engage and inspire others, the better off we are as a collective humanity. So I had the chance to train astronauts. And when they get trained, they get evaluated, just like you do at school. But they also evaluate the trainers. So I, too, got evaluated on my ability to communicate critical information to the astronauts when they needed it and how they needed it. And more recently, I worked with the Canadian Space Agency to develop future space projects. Where are we going to go in the future? To the moon, to the Mars, and onwards. So most of you might know space as a few things. Stars, telescopes, planets. You might know satellite dishes to get your TV in your homes. You might realize that there is broadband internet when you're flying in your planes, just like I used on the way here. That's pretty good. But it's much more than that. It is law and policy to understand how we can negotiate agreements between parties and countries. It is medical science and understanding how do we address surgery in space. It is understanding climate change and being able to know that the weather forecast I get on my phone is actually from a satellite that's up in orbit somewhere. A number of things are all connected to space, whether it's developing an artificial intelligence robot like the future Canadarm3, or if it's related to developing new types of food for people to eat while they're in orbit, or designing a new type of spacesuit for commercial space tourists that are going to go flying, hopefully, later on this year. There's all these different ways to get connected to the space industry. And some of it has been inspired in the past by science fiction and art. So, for example, for those of you that are Star Trek fans, the Next Generation, Captain Jean-Luc Picard used what's called a pad in the late 80s, early 90s. That inspired what you all know today as the iPad or the tablet. More recently, Alexander Gerst, a European astronaut, used what's called an artificial intelligence companion called Simon, basically a space Siri, which was loosely inspired by Rosie from the Jetsons. So whether it's many years ago with 2001 Space Odyssey that has inspired some of the things we see today, or today's science fiction shows that are going to inspire things in the future, I'm pretty excited to see what we're going to come up with next. So the space economy has commercial things, people that sell products and services, and they've got government investment, space agencies and companies. And most of what you see in terms of the television broadcasting you get, or the images you see on Google Maps when you're trying to find your way somewhere, that's all the commercial side of the space business. And the things that are more risky that governments are willing to take on, for example, going back to the moon and building a lunar space station, or trying to get ourselves to Mars. So just like when they tried to build a railroad from coast to coast, And in aviation, when the Wright brothers flew the Kitty Hawk for the first time, that was 100 years ago of history. And here we are today. So imagine what you're going to see in the next 20 to 30 years. We're already seeing it now. So whether it's working with international governments to build a lunar space station, or perhaps they're working as a Canadian on the next autonomous robotic arm, the opportunity is there. Take advantage and join us. Because perhaps you might even one day have a cup of chai on the moon. Thank you.